Hello again. I'm going to go over the cross product because last video I did not do an example for cross product. So I actually wrote down a couple of things so that I can save the time on this video. So what we are going to look at is A cross B. So that's what you have here, A cross B. And then I have the vector A written in the unit vector notation AXI hat, AYJ hat, AZK hat, and vector B is written as BXI hat, BYJ hat, and BZK hat. And after that, you all know that we are using the determinant or the matrix form. And then I put the I, J, and K at the top of the matrix, and after that I put the corresponding term. So here I have A, vector A, and then the corresponding X component, Y component, and Z component, they are listed first. And then I have the vector B, and the vector B goes as Bx, By, and Bz, and that goes in the second row. And after that, we discussed, we take the I hat first, and then we basically cover this column, and then we look at the leftover, and then we go from top to bottom. That actually gives you AYBZ, and then we go from bottom to top with the negative sign in the middle. You see the negative sign, don't forget that. And after that we write down the product. And then when we move on to the next one, J, we have to insert a negative like that over here, and that's the only place where you insert that negative from outside. And after that I actually drew this red box first, but we cover that column, and then we go again with the leftover top to bottom, which is the AX and then BY. That is the product that you see here. I'm sorry, AX and BZ. That's the product you see over here. And nothing inside the parenthesis changes. The negative in the middle stays the same. And then we go from BX and to AZ over here. And that's what you see over there. And after that, we repeat the same thing for the K. So there you wrote the K. And then we cover that column. And then you have AX, BY, AX, BY, and then BX, AY, BX, AY over here. Now I am going to do a quick example of this one. So let's write down. The best thing that you can do is work with me when I am doing examples. And I do not recommend you to memorize what we did above, because it is hard to memorize, right? And then let's say that we have a vector P, and the vector P is given to us as 2I hat minus 3J hat plus 5K hat. I'm just making up these things. And then the vector Q is given to us as 3I hat plus 2K hat. So you can see there is no J hat term in the Q vector. So it is best if you rewrite this vector Q, inserting a 0 for J. So you have 0J hat plus 5K hat. So when you take the product P cross Q, and there you have, we follow the same form as we used earlier. You write I, J, and K, and then you write the coefficients 2, -3, don't forget that, and there you have 5. And then the Q vector, you have 2 and 0 and 5. Now we follow the same strategy. First take I hat, and we cover this column, and we go from top to bottom, -15, 3 times, -3 times 5, and minus 0 times 5 is a 0. Then you insert the negative sign, and there you have it, -J. I told you why we are doing that in the class. and there you have negative 3 that and 0, that column is covered now. So you go with 2 and 5, 10, and minus 2 and 5, again 10. So that is what you have for j hat term. And then the k hat term goes as k hat, and then you cover the column again. I am using these colors just so that you understand what I am doing on the video, because I don't have the privilege of showing, like, you know, placing my pointer on the determinant and show these things. So let's do the k hat. 2 times 0 is 0, minus 3 times 2 is minus 6. So that's what we have. And the answer is negative 15 I hat and no j hat. 10 minus 10 is a 0. And there you have negative, negative, positive, positive 6 k hat. It is extremely important that you know your algebra, multiplying with negative numbers and also like, you know, squaring negative numbers. On the videos I see lots of errors when finding magnitudes in negative numbers. Now guys, not magnitudes actually, when you square a negative number, meaning negative 3, square of negative 3 actually is 9, but some students use it as a negative 9, which is incorrect. Now, as you can see here, P cross Q is negative 15 I hat and plus 6 k hat, right? Negative 15 I hat plus 6 k hat. You don't have, it's okay if you leave out the j hat, or if you leave it as 0 j hat, that's also fine. But the most important thing that you need to understand here is the vector product is a vector, or the cross product is a vector. A vector product or cross product, they both stand for the same thing. And then for dot products, it is completely different. And that's the example that I can give you for this one. Now, since I have a little bit of time left, if I go over the dot product, you can't like, you know, mix up things. So I suggest here that you go back to the previous video and watch this. If I take the same example as above, P and Q, and if I ask you to get the dot product between the two, let's write P, 2 I hat negative 3 j hat 5 k hat, right? 2 I hat negative 3 j hat plus 5 k hat. And then the Q was written as 2 I hat plus 0 j hat plus 5 k hat. So that's Q. Now when you take the dot product, here we go, P and Q, and you can write it down as 2 I hat minus 3 j hat plus 5 k hat and dot 2 I hat plus 0 j hat plus 5 k hat. Now those who understood what like about the dot product, they can follow from here. But the students who did not watch the previous video, I suggest that you watch that first before coming here. So here you have the like terms, 2 I hat and 2 I hat. 2 times 2 is a 4, so you have 4, and then you have I hat dotting to I hat, and that's the only surviving term when you take the dot product of 2 I hat with all the other terms on the other side. You can look at all the other terms. There you have the cross terms, I hat j hat and I hat k hat, they go away. And then the next term is negative 3 j hat. Don't exclude the negative sign. And the negative 3 j hat and 0 j hat, those are the only things that actually matter. In this case, it doesn't really. But I am just writing down the like terms. And the negative 3 times 0 is a 0, right? It is that is what it is, right? I mean, there's no coefficient for j, and that's why it went away. I mean, turned out to be 0. If you would like to write it as negative 3 times 0, and then go from there, that's fine. And then the last term is 5k hat, and I'm going to go with the like term there as well. So here you have 5 times 5 is 25, and k hat dot k hat, that's the only surviving term. Now j I hat times I hat dotted to I hat is 1, j hat dotted to j hat is 1, k hat dotted to k hat is 1. So 4 times 1, and there you have 0 times 1, and there you have 25 times 1. I know that I am going like into like trivial details here, but I am doing that because I have seen many errors over the previous like quizzes that we did in the class, and that's why I am doing all these minor details, showing these minor details. Now you can see that the p dot q ended up as a scalar. This has no vectors. P dot q equals to 29. That's it. And this is a scalar. So this is what you have to do when someone's asking you to find the dot product between two vectors. If someone asks you to find the angle between P and Q, then you have to use the, again I am not going to go into details here, but I am writing it from the previous video. We discussed cosine Q equals P dotted to Q, and then the magnitude of P and the magnitude of Q. And what is the operation in between P and Q down here, guys? Here you have P and Q, and the operation between is simple multiplication. Some students used it as a sum, which was incorrect. So here, since we already know P dotted to Q from here, you can simply write it as 29, and then in the magnitude of P is taken as square root of, let's see what P is, 2 square. I like that example because you have a negative 3 next, plus negative 3 square plus 5 square. So when you have a negative number, please remember to put that in a parenthesis like in here. And then you have square root of the rest, which is 2 square, 0 square I don't have to write, and 5 square. Now you just do the math and find what you end up in here. Okay, so you got 29 in the numerator, and inside the denominator, in the square root, the first square root, you see a 4 plus a 9 and a 25. And then the second one you see 4 square root 4 plus 25. And then you can find the cosine theta, and once you're done with the cosine theta, you can find theta, the angle, and make sure that you know the mode of your calculator. It doesn't matter whether it is in radian or degrees. Degree is the preferred form of giving an answer at this point. So if you still have your angle like the calculator in radian mode, you can give the answer in radian, no big deal there. And there you have square root of 38 I believe, and there you have 29. And do the math and then find the answer. This is theta. So I'm going to stop because the video is getting too long.